Okay, so for decades, right, one of the biggest hurdles for AI has been trying to match, the peaks of human thinking. Well, a new paper says it's finally happened. AI has just done something that most people thought was years, maybe even decades down the road. All right, let's get into it.
The big question has always been, can a machine really think? Can it have that spark of creativity, that insight you need for super high-level math? We're not talking about just crunching numbers, but actually innovating. And, well, it looks like the answer just dropped, and it's a big one.
So check this out. On a totally fresh set of problems from the upcoming 2025 International Mathematical Olympiad, problems it's never seen before, an AI system scored an amazing 5 out of 6. I mean, that's basically a gold medal performance for a human. The question is, how in the world did it pull that off?
Okay, so to really get why this is such a huge deal, you've got to understand what we're up against here. We're talking about the International Mathematical Olympiad, the IMO. And let me tell you, this is not your average high school math quiz, not even close.
The IMO, it's like the ultimate test for pure creative mathematical thinking. It's not about memorizing formulas. It's built to find out if you have that deep insight, that originality, if you can build a rock-solid logical proof from the ground up. It's all about forging a path where there isn't.
And this is where things get really interesting. You see, AI is usually amazing at the stuff on the left side of the screen, right? Calculations, spotting patterns in huge amounts of data, it eats that for breakfast. But the IMO? That requires everything on the right. Creativity, real insight, coming up with something new. That's exactly why older AIs have just completely fallen flat here. I mean, they couldn't even get close to a bronze medal.
Which, makes that almost perfect score even more mind-blowing. So let's dig into the actual result and why we can be pretty sure this is the real deal.
Okay, so 5 out of 6. That is a massive, massive jump from anything we've seen before. And what's so cool about this isn't just the score itself, it's how they did it. This wasn't just about taking a super powerful model, in this case it was Google's Gemini 2.5 Pro, and just throwing it at the wall to see what sticks. No, they used it in a really, really smart way. And to make sure this was a fair test, that the AI was actually thinking and not just, remembering something it saw online, the researchers were clever. They used problems from the brand new 2025 IMO. That means there's no chance of what's called data contamination. The AI couldn't have seen these problems or their solutions before. It had to figure it all out right then and there.
So what's the secret sauce here? What made it all work? Well, the real breakthrough wasn't just a bigger, beefier AI. It was a smarter process. The researchers created this thing they call a self-correction pipeline. And honestly, that seems to be the real hero of the story.
It works kind of like a loop, a really powerful one. First, the AI spits out an initial idea for a solution. Then it immediately tries to make it better. But here's the magic part, step 3. Another part of the system acts like a super strict teacher with a red pen. It checks for any mistake and writes up a bug report. Then the first AI has to read that report, fix its own work, and submit it again. And this just keeps going. Generate, check, fix, generate, check, fix, until the whole thing is absolutely airtight.
And this quote from the paper nails it. They compare it to the peer review process in science. A scientist writes a paper, sends it to other experts, they find flaws, and the author has to revise it. It's the same idea. And what's really brilliant is that even if the verifier AI gets something wrong in its feedback, the whole process just pushes the solver AI to be clearer and more precise. It ends up making the final proof even better. It's a system designed to be tough, even on itself.
So you can really think of it as a team of 2 AIs working together. You've got the solver, who's told, hey, your job is to be super logical and rigorous. Don't just get an answer, get it right. Then you have the verifier, who's like this incredibly picky editor, checking every single line for mistakes or gaps in logic. And that loop forces them to cooperate, turning what starts as a messy first draft into a perfect, polished final proof.
But, nothing's perfect. And to really get a handle on what this can do, and what it can't do yet,
we need to look at both the amazing wins and the one problem where it stumbled.
And here's something that's just wild. At first, for some of the problems, they gave the system a little nudge, a general hint like, hey, maybe try using induction. But then they went back and were able to solve all 5 of those problems with 0 hints. None at all. And that's huge because it proves the pipeline is the real star here. It's the process itself that's unlocking the AI's hidden ability to reason.
But it did hit a wall on problem 6. And the researchers are super upfront about why. The AI's whole solution was built on one single bad assumption right at the start. It was just wrong. And that's actually a really important thing to know. It shows us that this system is powerful, for sure, but it's not foolproof. It can still make a big, fundamental mistake in its logic.
So what's the big picture here? What are we supposed to take away from this? Because this is about way more than just a math competition.
This next quote really gets to the heart of it all. The big news isn't just that an AI is finally smart enough to tackle the IMO. The real breakthrough is the method. It's this structured, self-correcting process that can take all the raw, sometimes chaotic potential of a big AI model and shape it into something solid, logical, and something you can actually trust.
So when you boil it all down, the main takeaway is this. The future of AI isn't just about building bigger and bigger models. It's not just about raw power. It's about designing these smart, self-critical systems. This pipeline shows how you can unlock the reasoning abilities that are already hiding inside these models by systematically finding and fixing all the little errors and gaps that they make on their own.
And that really changes the game. We're at a new frontier now. The conversation isn't really about if AI can reason like a human anymore. It seems like it can. The new, much more interesting question is, how do we build the systems around it to make that reasoning something we can count on, to make it reliable?